Okay, we welcome you back. The channel is PSSB and the name is Richard. Like we always do, we urge you to subscribe. Yeah, for your own benefit, actually. So now comes this question. The question says, give 4 ways in which the turning effect, which is torque of the coil, can be increased. So already we identified that this one is a motor. And what does a motor do? It is switched on, electricity enters, and it rotates. It can be applied in so many um, cases where rotation is needed. Now, the question is that if you want stronger rotation, faster rotation, what changes can you make to this motor? So if you want a bigger turning effect, bigger torque, what can you change? So let us look at what we can change. We can change the strength of the magnets used. You make them stronger. So that's one, increasing the magnetic strength. Two, you can increase the potential difference across the coil by increasing the EMF of this battery. Okay, that's two. So when you increase the EMF, you increase the potential difference across the battery, and the torque will increase. That's two. Thirdly, you can, for us, we represent only one wire, one coil, one turn of the coil. But in the actual practice, in the actual sense, these are a number of turns, sometimes thousands of them. So when you use bigger number of turns, the torque will increase. So that's the third one, increasing number of turns of the coil. The third one, you can increase the area of the coil using a bigger area. There are other factors which you can do. One is using a soft iron core. In practice, these wires are wound on the core. So when that core is made up of soft iron, electromagnetism occurs faster. So those are the ways in which we can increase the turning effect of this coil. Let us put them down. So those are the 4 changes which we can make to this setup to increase the torque. So there, let us look at the next question. Okay, then we come here. The question says, name the component which becomes an electromagnet during the operation. So which component here becomes an electromagnet? You have to know that what you call an electromagnet is the magnet which has magnetism only when electric current is passing. So this magnetism, you can switch it on and you can switch it off. I repeat, it is a magnet during only when electric current is passing. So our magnets here, south and north, these poles are permanent. So those ones are not electro. So which one becomes an electromagnet? It's the coil. So as electric current passes through the coil turns into an electromagnet. So in this setup, during operation, we have 2 magnets. We have an electromagnet here and permanent magnet. So what happens when the 2 magnets are next to each other? They either attract or they repel each other. So those attraction and repulsion is what causes the turning effect. So back to the question. The answer is coil. The coil is the component which becomes an electromagnet. After that, then we come to this question 1.8. It says, name the component which ensures continuous rotation of the coil. So remember what happens here. You have to remember this, that what you call the commutators or the split rings are not glued to the carbon brushes. They are just pressing on them. So this coil is free to rotate. Now, but the question is, what makes it rotate continuously? What component plays a part there in the continuous rotation of this coil? The component is split rings or commutator. Okay, that's that. Then comes this question. It says, briefly explain why the component mentioned in 1.8 above causes continuous rotation. So we said it's the split rings which ensures that the coil rotates continuously. But how does it do it? Okay, this is what we have to know. That, remember I told you carbon brushes are just pressing on what? On the split rings, on the commutators. So when the coil rotates, here our assumption is that it's in horizontal position. When it rotates and it reaches the vertical position, it loses the contact with the carbon brushes, but it does not stop. It continues to rotate by virtue of momentum or by virtue of inertia. So in other words, it swings, it reaches the vertical position. In the vertical position, there's a gap. The gap is the one which separates the two split rings. It jumps the gap, despite the fact that by that time there's no applied force, because there is no electric current passing. The gap means that the coil, the split rings have lost contact with the carbon brushes, but it continues to move by virtue of inertia or momentum. So after that, what happens is that the split rings which was on the left comes to be on the right, and the one which was on the right comes to be on the left. During that time, the current which was flowing in the coil is reversed. Surprisingly, when that reverse occurs, the force is in one direction. So that's the part the coil plays to ensure that that's the part the split rings play, which ensures that the coil rotates in one direction. What does it do? By reversing direction of current after every half cycle. So let us write that one down. So that is that. The split rings ensures continuous rotation of the coil by reversing direction of current in the coil after every half cycle. So we got the next question. Okay, then we come to this closing question. The question says, considering the position of the coil, state whether it will experience a maximum or minimum turning effect. So when you look at this setup, our assumption is that the coil is horizontal. So if the coil is horizontal, what does horizontal position yield in accordance to the magnitude of the turning effect? Okay, this one requires you to borrow knowledge which we used in grade 11, though it's a bit tricky. We know that for maximum force, the conductor and electric field must be moving perpendicular to each other. That's what you have to remember. Now, it is very easy for a learner to be corrupted by thinking that because the coil is horizontal here and the field is also horizontal, that this is the other side. Actually, I don't want to mention it because I don't want to corrupt your mind. The answer here is maximum. Okay, how does it come to be maximum? If you label this A, and you have B, and you have C, and you have D, you have to remember that the sides which are resulting into rotational forces, or which are forming the couple, which is resulting into couple are two forces which are acting in the opposite direction, resulting into rotation. So the sides which are resulting into rotational force is A and C and B and D. And when the coil is horizontal, these sides are moving up. This side is moving up, the other one is moving down, and the field is moving across. The field is from south to north. So the angle being made when the coil is horizontal is 90, and that is the angle which results into maximum torque. When the coil is vertical, when the coil is in a vertical position, it is minimum force experience, because these sides, which side? Our side AC and the BD are moving perpendicular, are moving parallel to the magnetic field. And when the motion is parallel to the magnetic field, it leads to minimum or zero torque. So the answer is maximum. Thank you. Now, like we say, don't forget to subscribe. And the channel is PSSB, Physical Sciences, Silver Bullet. We'll see you next time.